Good morning, all. Let us see how we solve this GATE 2025 question uh, in the subject structural analysis. So, the question says the figure shows a propped cantilever. You see the propped cantilever beam here with uniform flexural rigidity and subjected to momentum, which is clockwise, given to you. Consider forces and displacements in the upward direction as positive. Find the upward reaction at the support B when the support is settles by delta. Okay, so you need to find reaction at B. Okay, this is the question. So here, if you see, there are two things which are contributing to reaction. One is the applied momentum. Okay, the second one is the settlement given. So these two are contributing to reaction at B. So we need to try find the two things separately and then add up, okay, according to their sign. So now first I'll take moment applied at the end B. So let us see what will be the reaction value from applied moment. Okay. So try draw a partial free body diagram. Okay. So this is partial free body diagram. Okay. I just removed support B and applied the reaction. Okay. Now separate this two forces. Now it is like cantilever applied by two forces. Okay. So one is RB and another one is momentum. Plus I'll split into this two cases. Okay. So this RB. Right. Now let us find. See, because of this moment is going to bend like this. Because of RB, this is going to bend like this. So let us try find this deflection delta 1, then find delta 2. Finally, delta at B shall be equal to 0 because of the support here, it can't deflect. Okay. So which means delta 1 plus delta 2 shall be equal to 0. So what is delta 1? So from your previous knowledge from structural analysis, delta 1, if there is an applied moment for a cantilever at free end, it is ml square by 2ei. Okay. Similarly, when you have a point load at free end, the deflection value is p. That means now p is rb l cube by 3ei. Okay. So the question is all the upward deflections are positive. So this is downward. So I'll give it a negative sign here. So now if you apply this condition, it is minus ml square by 2ei plus rbl cube by 3ei is equal to 0. Okay. So now what will be the rb value? So solving for this, rbl cube by 3ei, which will be equal to ml square by 2ei. So ei gets cancelled. L square goes, L will remain here. So now RB is equal to, so 3 goes to the right hand side, 3m by 2L. L remain here. So send L to the right hand side. So this is the reaction contribution from moment. So when you apply a momentum, the reaction will be 3m by 2L, which is upward. Okay, upward. So if you see the answer that is being given, you see there is a answer C. So where 3m by 2L is part of moment, reaction from moment. Now let us continue. How about the reaction contribution from delta? It is settlement. So consider the beam again. So you have a support here. Now you remove the moment. Okay, we have found the contribution from moment. Okay, now the delta, try draw the deformed shape. Okay, so this is now going to bend like this. So this, from your earlier knowledge of structural analysis, this is going to be 3ei delta by L square is the moment developed at support A. This is support B, which is settling down by an amount of delta. Okay, so to balance this moment, you need to, this is an anti-clockwise moment, you need to have a clockwise moment. Okay, so equilibrium exists with the clockwise moment. Okay, so now if you see the free body diagram of the beam, so now the reaction developed here should be downward, reaction here should be upward, and a moment of 3ei delta by L square. So these two shall be equal and opposite to generate moment. So I'll call it as R, and this is L, span L. So total moment from couple is R into L shall be equal to the 3ei delta by L square. So which will give you R value 3ei delta by L goes to the right hand side, L cube. And you can see this is downward. Okay. So the answer C, what is given here, okay, consists of minus 3ei delta by L cube. Okay. So this is the right answer. So what you can see here is this one is contribution from moment, reaction contribution at B from moment. This is reaction from settlement, contribution from settlement. So this is how you can answer the question. So basically the concept here is to apply principle of superposition, separating the two applied forces. One is applied moment, another one is developed reaction. These two you need to separate. The principle of superposition is applied here. Okay, and the further, a case of settlement is taken where one end is hinge, the other end is fixed. So you might have also learned that the fixed beam from your knowledge of structural analysis, if this settles down by an amount of delta, okay, so this is going to be the nature of bending, and the moments developed here will be anti-clockwise 6 ei delta by L square, same 6 ei delta by L square, and the reactions will be, you see this is anti-clockwise moment. So for clockwise moment to be developed, there should be downward reaction 12 ei delta by L cube. This reaction is also 12 ei delta by L cube. So this is the case for fixed beam, whereas here the one end fixed, other end hinge case. This is the moment developed. The hinge at the hinge end moment developed is zero. It can't have moment. Okay. So this is the complete analysis and the concepts behind solving this GATE 2025 question. Right. Thank you.